So I'm going to talk about the story of a journey planner at Capitaine Train. So what Capitaine Train is, my colleague talked about that this morning, but I'm going to send a little reminder. So we are a company which sells train tickets all over Europe, hopefully. And so we connect to the carriers' APIs and then hopefully sell their train tickets. So we currently cover France, Germany, and Italy. Basically, and a bit abroad. So France goes, well, you have French trains which go to England, for instance, or Spain, and things like that. So when you have multiple carriers, well, there are nice things that you can do. Let's say you want to go to Paris, from Paris to Frankfurt, then you can compare the prices of SNCF and DB. So SNCF is in this, I don't know the color because I'm colorblind, but anyway. And then you can compare the SNCF price to the DB price. But this strategy does not work when you want to go, let's say, from Paris to Hamburg, because SNCF doesn't go to Hamburg, so you're stuck to basically asking DB price, and then the client has to pay the DB price. And that's the same for Bordeaux. If you want to go to Bordeaux to Frankfurt, it doesn't work. And worse, it doesn't work if you want to go to Bordeaux to Hamburg, because, well, nobody is able to sell the whole route, or very expensive. So we wanted to make a journey planner. So a journey planner is just, you have a bunch of timetable, a database of timetable of trains in Europe. And so I was hired basically to do that. So we started with proof of concept in Ruby, because everybody works in Ruby in our company. And so I tried Dijkstra, not really brain surgery, but it worked. And it was, well, we were very excited because it was making journeys, and just we knew how to do Paris to, let's say, Bordeaux to Hamburg. We knew that the train had to go from Bordeaux to Paris, then Paris to Frankfurt, then Frankfurt to Hamburg, and then we could split the journey and then sell each part for each carrier. But it was very slow, very, very, very slow. Not possible for our purposes. It was taking 1 second for each journey, and we wanted all the journeys for one day because we don't want to go back and forth from the APIs. So we switched to a compiled language called Java. I think you have all heard about it. And we had the Dijkstra was ported to Java, and it did the job pretty well, and we got a factor of 50 in terms of performance. All about the algorithm was taking about 100 lines of code in Java, and the rest is boilerplate to read the data, to interact with the rest of the world, and so on. And we still had performance issues with this algorithm. The most time spent was looking if a train was going out of a station for each day. So it was a problem of algorithm and data. And so we hired someone else to do it in C++. So the algorithm was changed and the data was changed. The data was now, each train was split into, we had a data record for each train. For each single day, we had a record for the train, so we didn't have to search for a loop for the trains to see, is that train running? And so we got a factor of 10 approximately, and there's still an argument inside the company because we say, is it the language or is it the algorithm which improved the performance? My colleague said, oh, the algorithm is tuned to be efficient when the records are really close into the memory. And so it is efficient because of that, and we didn't have that in Java. And I called bullshit. And so it should be efficient in Java too. Okay, maybe a performance of 2, we would have an impact factor of 2 or 3, but it should be efficient, and it should be sufficient for our purposes. It's not because my colleague doesn't like Java that it shouldn't work in Java. So we opened the contest inside the company, and so we had the algorithm, and we had to write proof of concept. So some of my colleagues wrote that in Haskell. We had a proof of concept in Ruby. We had a concept in C++. and there's missing the C and the Java. Okay, that's finished, I think. But we are lazy, so we didn't do it. So the contest is still waiting 1 year later, and then we're still waiting for me to write the Java and the C. So that's it.